Hello everyone, welcome to Math World. This video is to discuss topic of Statistics 1, which is combinations. Okay, so basically the combinations means the number of selections, right? So combinations is referring to selections, which means the arrangement is not important, right? So basically there's only one formula, that is NCR. Okay, this NCR means n different objects, right? N distinct or different objects. We select R of them. Okay, so select R, which means the selected items or selected objects will be different objects. Alright, so this is the only formula for the combinations. Okay, so let's move on to next part, which is our question number 1. So for question number 1, find the number of ways in which 12 people can be divided into two groups consisting of 7 and 5 people. So A, basically there are 12 person here. We need to split them into two groups, 7 and 5. So since the arrangement is not important, which means we are going to use the combinations formula, that is the NCR. Okay, so we know that 12 different person, alright? Therefore, first group, we need 7 person. So our number of selections or number of ways, it will be 12C7. So after you have chosen 7 from 12, so now you have to minus. So when you minus this 7, okay, from 12, that means remaining will be 5. So this 5 automatically will be in the second group. So you have two choices here. You can just write times 5C5, or probably you can just write 12C7, because the remaining will be in the second group. Okay, so both will be giving you the same answer, 792, because 5C5 is basically 1. Alright, so you can leave your answer in this form. So done for the A. Now for the B. Now you have to divide this 12 person into 3 groups, whereby first group or the groups consisting of 4 person, 3 person, and another 3 person, which include 2 particular person, which means now no longer 12 person. We are arranging 10 person. Okay, so which means now here I will write, out of 12 person, that 2 particular person probably I label them as A, B, and then now here I have 10 others. So total will be 12 person. Okay, then from here, the 10 others, right, I have to split them into 3 groups. So 4, 3, and 3. So when you look at this diagram, okay, obviously I know that I have to ignore these two A and B. So from this 10 person, I have to split them into 4 person in a group. Okay, so it will be 10C4 first, and then followed by, and the second group is 3 person, and the third group is 3 person. So that means now here, since we know that, okay, initially 10 person, so you minus 4 now becomes 6. So from the 6, I got to choose 3. So which means the working becomes 6C3. Okay, 6C3. And then now, lastly, so from the 6, since you have chosen 3 person, that means you minus 3 from the 6. That is the remaining of 3 person. So from these 3 person, you have to put them in a group. So again, the working might be times, or I just write times 3 times 3 times 3C3. Okay, why here times and not plus? Because times means n. Alright, so you have chosen first group and second group and third group. Therefore, we are using times. So this will be the number of ways to form the groups. Okay, so or same as the previous question, you can just write number of ways, probably 10C4 times 6C3. So we know that the remaining person will be in the last group, which is another 3 person. Okay, so from here you will be getting the total of 4,200 for each of these. So this is how we solve this question. Okay, now for question number 2, find the number of teams of 10 that can be selected from a group of 16 players based on the conditions below. So A is no restriction, so means no special conditions. So which means now here A, basically there are 16%, I need 10. Okay, so the number of teams, so here just involve selection. Therefore, I will just write 16, choose 10%. Therefore, you will be getting 8008, 8008 teams that can be formed. Now, move on to B, the twins players, and at most, one of the two cousins are selected. So which means now, out of this 16%, okay, I have twins. Okay, then here I have two cousins. So if you're twins and two cousins means that already 4%. So you have to minus 4 from 16. That means you will have another 12 others. Okay, but now when you need to choose the teams, right, the team, so must include these twins. So from here, I'm going to choose 10%. This 10% have to include the twins. So the twins already 2%, and then at most one of the two cousins. At most means maximum. So maximum one means that you can either choose one cousin or 0 cousin, means that you are not choosing anyone. Okay, then here you have to choose others. All right, to make it to 10%. So now here I will just write down. It will be probably, I choose two twins. Okay, the twins. And then one cousin. So here 2, right? Twins means 2%. 2 plus 1 is 3. That means I have to choose 7 others. Okay, or here I have to choose the twins. So twins already 2%, and then I do not choose cousin. So if I do not choose cousin means that I need another 8. So 8 others. Alright, so that means now here to form the teams or to get the number of teams, it will be the twins is just one way. Okay, one way to choose the twins, and then out of 2 different cousins, I need to choose one of them. So the number of selection, it will be 2C1 because 2 different person, and now I need 7 others. Okay, so initially they have 12 others. So from these 12 others, I got to choose 7 others, which means the working is 12C7. Okay, and then now here all means plus, right? So n is times, all is plus. And then twins, one way, times 8 others. So from these 8 others, I need to choose it from 12. So it will be 12C8. So this will be the working for this question. And then when you calculate, the first bracket is going to be 1584. And then the second bracket, it will be 495. So this is going to be 2079. So we have so many teams that can be formed. Alright. Okay, next question, number 3. 6 letters are selected from the word statistics. We need 6. Calculate the number of selections based on the conditions below. Now contain exactly 2 T's and exactly 3 S. And then the B is exactly 2 S. Alright. So now from statistics, STATISTICS. So basically there are total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total of 10 letters. Now out of the 10 letters, I have 3 S. Okay. Then I have 1, 2, 3, 3 T. After that, I have 2 I. Okay, here 2 I. And then followed by A, C. Okay, so 3 plus 3, 6 plus 2 and plus 2, there will be total of 10. Alright, so after you have confirmed all of these are correct, then now we need to solve exactly 2 T's and 3 S. So remember, from here I need to choose 6. Okay, 6 letters. So for the A, if I need to get exactly 2 T and 3 S, here already 5 letters. So then I need to choose another 1. So the 1 might be chosen from I or the A or C, right? So what I need to do is I will just consider either I choose I to make it to 6 letters, or probably I do not choose I. Okay, I choose A or C. So now, number of selections based on the first condition, it would be, okay, now for this 3t and 2t, I mean this 2t and the 3t over here, since they are identical t means that only one way to choose the 2t. We are not going to use the 3c2. If you use 3c2, that means you assume you are given 3 different t's, then you choose any 2 of them. But then these 3 t's are identical t's, right? Therefore, we are going to just choose directly, means one way. One way to choose a t, and then same goes to the s, right? So these 3 s and here are identical s. So there's only one way to choose the s. Times this I, okay, both identical I means one way. So this is how we get it, right? Or probably you can just write 1 directly instead of 1 times 1 times 1. All is plus, remember? So to get 2t and 3s, so I get 1 times 1 times, you need to choose 1 out of A and C. You can only choose 1, so that the total letters will be 6. So that means now here I have 2 choices, either A or C, but I just need 1. Okay, so from here it will be 1 plus 2. That means the answer is 3. Okay, so this is how we solve the A. Now for the parts B, contain exactly 2s. Okay, so now if contain exactly 2s, B, just 2s, which means now here I will draw a table. Okay, instead of writing down or listing down all the outcomes. So now my table must have S, T, I, and AC. So I will have to draw 4 columns. So basically I have 3s, 3t. So this is 3s, 3t, 2i, and then A and C. Okay, now remember we need to get exactly 2s. So which means now here I will write 2s. Okay, so now when you refer to here, to make it to 6 letters, so remember 6 letters and exactly 2s. So I will have to say probably I consider no t, and then this is 2, this is 2. Okay, and then probably 2. Now I cannot write 0, 1 and 2 here, because if I write 2, 0, 1, 2, the total here is only 5. Okay, so which means now here I may consider the 0 is in the I. Okay, then here might be here 2, here 2. So which means if you consider there's a 1, 0 here, we can say the 0 maybe in the T, maybe in the I, or maybe in the AC. So here I will say it would be 2, then now the 0 is at the AC. So here 0 at the AC, then here will be 2, 2. Okay, so now I can say that it would be 2. Instead of 0, I change to 1. Okay, so here it becomes 2, 1. And then if here is 1, it might be here 1. So here is already 4, then plus another 2. Right? And then it could be, okay, 2. The 2 now, there's 1, 2. Then 2 times of 1. So the 2 can be in the I or in the T columns. So you just make sure do not miss out any of the combinations. Right? So my 2 now is in the I. So that means this 2 will be 1. And now my 2 is the T. So here again 2, then here 1, 1. Right? So I have considered 1, 0, then 1, and then I consider 2. So if here is 2, it might be, okay, 1 1 already considered. So that means now here I will have to consider 3. Okay, so when here is 3, here might be 0, this is 1. Alright, so because you have 3 t's here, and then now I can just remain the 3 in the middle, I mean for the t, then the 0 and 1 I will swap. So here becomes 1 0. Right, so just to check, any combinations are missing from the table over here. So we have considered 0, 1, and 2, and 3. Okay, so I think that's all for the combinations. Right, so now my number of letters, okay, this is our number of selections. So here I will write number of selections. It will be, okay, now when you look at here, when you look at the table, we have 3s, we choose 2, one way. Okay, we don't choose any t, 2t we choose 2, that means we just have one way to do it. And then AC we choose 2, so one way to take it. So I will here I will just write 1. I will not write 1 times 1 times 1 anymore. Then plus for the second form, okay, because all these are all. Right, so for the second case, probably one way to take 2s, one way to take 2t, and then one way to take AC. So here 1. As long as you are taking for all of them or for part of them, right? Just like the S, T, and I, then it will be just one way. So same goes to the third case. Okay, we take one way to take S, one way to take T, and one way to take the I. So one way. Because we are not choosing any A or C. Then the fourth one, it will be one way here. Okay, identical T one way, identical I one way, and we are choosing both A and C. So also one way. Then plus, now the next one, okay, which is this. So one way to take 2s, one way to take 1t, one way to take both I, but then for the AC, okay, we just choose 1, which means we have to consider 2C1 here. So my working is 2C1 because the rest are one way. So plus, okay, as long as you see A and C, out of A and C, you take 1, that means you have to use 2C1, okay, here. Right, so I will have 2C1, 2C1 for these two orange color. So this is actually the green color. This is a green color. So the orange color will be 2C1 because the rest we only have one way to do it. So 2C1 plus 2C1, and then lastly, okay, so we take we take 2S, all T, and only one I. We do not bother the A and C. So there's only one way to do it. Right? So this is how we consider the number of selections. So when you get the total over here, this is basically 11. So we have 11 ways to get the requested numbers, requested letters. Alright, now next question number 4. A mathematics final exam question paper consists of 7 questions in parts A and 4 questions in parts B. So candidates must attempt 6 questions. The order in which the questions are chosen does not matter, means that you can choose any questions in any order. Alright, so calculate the number of ways in which these 6 questions can be chosen based on the conditions below. A, no restriction, which means now here basically I have 7 questions from A and then 4 questions from B. Okay, so here total is 11 questions, but then you have to choose 6. You have to answer 6. So basically here 11 questions. Now A, no restrictions means you can choose any 6. So it means when you look at the question over here, it's mentioned the order does not matter, means that as long as you answer it, we do not bother the order, the arrangements of the questions. Therefore, we are going to use the selection or combinations to solve this question. Okay, So from here, if no restrictions, basically from this diagram, I will say it will be 11C6. Right? Because you are given 11 questions in total and we just need to answer 6 questions. So 11C6, it is 462. Okay, done for the A. And now for the B, candidates must choose at least 4 questions from A. So now here, I will write my B. Okay, probably this is my A. So my B, at least 4 questions. Which means now here, okay, I have to choose probably 4 A's. And then to make it to 6 questions, it will be 2B. 4 questions from parts A and 2 questions from parts B. Or probably 5 questions from A, 1 question from B, or 6 questions from A. Okay, so initially there are 7 questions from A, so I need 4 only. So that means it will be 7C4. And at the same time, okay, I need to choose 2 questions from B so that it will be total of 6 questions. So remember, n means times. And then I need 2 from 4. So it will be 4C2. So this is the working for the number of selections when you choose 4 A's and 2 B's. Now all is plus. So from 7 A's, I choose 5. And from 4B, I choose 1B. Okay, from 4 questions in B, I choose 1 of them. All is plus. I need to get 6A, means that from 7A, I choose 6. Okay, so then from here, I will say the first one is 210, and then the second one is 84, and the last one is 7. So lastly, you will be getting 301. So this will be the number of selections for the questions. Okay, now see. Candidates must either choose both question 1 and 2 in parts A or choose neither of these questions. Means that now, okay, from the 11 questions, you have A1, A2, okay, and then we don't bother other questions from A because either you choose these 2 questions from parts A or you do not choose both of them. Right? It's mentioned here. That means now I will draw my diagram into this form. 11 consists of or split into A1 and A2, then another 9 others. Okay, so these 9 others means that the remaining questions from the parts A and also the all other questions from the parts B. Okay, so now my concern is either I choose A1, A2, and then remember we still need to choose 6 of them, so it will be another 4 others. Okay, or I do not choose A1, A2, means I will direct choose this 6 from the 9 others. So here will be 6 others. So this will be the idea to solve this question. So from here, I will just write number of selections. It will be, okay, since A1, A2 are selected, right? So there's only one way to do it. Followed by, I have to choose another 4 others from 9 others over here. Right, that means it will be 9C4. If you need to skip the 1, it's okay. Alright, you can just direct write 9C4. All is plus. So now I need to choose 6 others from 9 others. The working will be 9C6. Okay, so when you use calculator to do the calculation, for the first one, 9C4 is basically 126. And then 9C6 is 84. So the total of this is going to be 210. Alright, so that's all for the videos. Okay, so thanks for watching. Please subscribe to the channel and share this channel with your friends if you enjoy watching my videos. And also stay tuned for more upcoming videos. Thank you everyone. Bye.